As we left off at the end, really, of section 6.2, in particular, we were kind of changing topics, so it was a reasonable place to stop. And what we're going to take a look at is estimation. And when we estimate, there's lots of ways you can estimate. There's not necessarily always one that's better or not as good as another. But oftentimes, convenient fractions are nice ways to estimate. So convenient fractions are fractions that are roughly equal to what we're given, but they're easier to work with. And so these are some examples of some convenient fractions. 0, 1/2, 1/3, 1/4, 1/5, 2/3, 3/4, 1. Okay? And those are just, of course, numbers between 0 and 1 that are in there. There are some questions that you're going to be simply given a fraction and they just say to estimate it. And you kind of can pick how you're going to estimate it. And there are some questions that actually give you some options and they say decide whether they're closer to 0, 1/4, 1/2, 3/4, or 1. So just be careful to pay attention to the directions that they're giving you. I wanted to do a couple of examples where you have less to go on. I feel like almost when they give you the 0, 1/4, 1/2, it's almost like multiple choice. And you're going to have a pretty good idea of where to go with that. If that's not the case, and as we're working in groups, of course, you can ask. But these right here would be some examples of ones where they're just asking you to pick a convenient fraction. And my answer and Emma's answer might not necessarily be the same, but they could both be adequate answers of convenient fractions, like it's possible. So we're going to do 12/78 first. And it's kind of nice to do it as a rounding technique with the numerator and denominator separately when they don't necessarily look nice together anyway. So like 12 is pretty close to 10, right? It's pretty close to 10. And 78 is pretty close to 80. So we can kind of adjust them slightly into something that divides nicely or pairs down nicely. So this one would be approximately, well, this part of it would be 1/8. So one approximation for 12/78 would be about 1/8. It's about 1/8. So if somebody tells you that 12 out of 78 of the first graders in your school have a certain disability, 12 out of 78 is a weird number. But if they said 1/8, you'd have a pretty good idea of what that looks like in a classroom. You might even think in your mind, well, that's a little bit more than 1/10, right? 1 out of every 10. 1 out of every 8 has this specific situation. The other part of the directions asks us to estimate if we are high or low. High or low is something that you can determine with your calculator if you want to turn them into decimals. I'm not going to be too particular about it. But there are things that you can also look at from the original fraction to your reduced fraction to make that decision. For example, if we look at the numerator going from 12 to 10, and we made the numerator smaller, that makes the whole number smaller. Right? But if the denominator gets larger, that also makes the whole thing smaller. Right? If you divide by something bigger, right? If you divide by 4 and then you divide by 5 and then you divide by 6, your fractions are actually becoming smaller because you're dividing whatever the situation is into more pieces. So in this case, we made the numerator, well, because the effect on the numerator made the whole fraction smaller, the effect of the denominator made the whole fraction smaller. So my fraction at the end is a low estimate from what I started with, right? It's smaller than what I began with. So this is a low estimate because I did something to the numerator and to the denominator that made things smaller. Okay, so B would be an example where maybe you don't change both of them like I just did. Maybe changing one of them is enough. In particular, the denominator probably is enough to change because if I simply made the denominator 1,000 and left the numerator with 2, that's very nice to simplify, right? I would end up with 1/500. So you don't necessarily have to change both pieces. Sometimes you want to and sometimes you might not want to. There's one in your group work as well that uses an example kind of like this, but it gives it that multiple choice style. Is it closer to 0 or 1/4 or 1/2, right? 2/1001 or 1/500, that's small, right? 1 out of every 500 is a very small number. That'd be closest to 0 in that particular situation. Now, back to the one that we have. I didn't change the numerator, I only changed the denominator. So if I changed the denominator and actually made it smaller in the denominator, what effect does that have on the whole fraction? It makes it larger. Right? If the denominator becomes smaller, you're dividing by fewer pieces. Right? It's like taking 2 cakes and dividing them among 1,000 people instead of 1,001 people. And so it makes the whole thing larger, which makes this now a high estimate. Yeah, Brooke.
What if you're not a column that, in the numerator, made it smaller and the denominator made it larger?
Yeah, then you can't really reason it like this at all. It's got to affect both the numerator and the denominator the same way, or you're going to have to use a different method for trying to figure it out. So estimating with fractions would be one way to do that. Your calculator could be a help for that. I'm not sure that you have any that are going to put you in that position, but if you do, that's probably my best suggestion. Any questions on either of those questions or that idea? All right. So we'll do group work for this at the end of class, but for now you can just set it aside and pull out 6.3.